All right, hey guys, I'm going to go ahead and get started. I just want to do a check first. Can you guys see clearly and can you hear my voice clearly? So if you can hear my voice clearly, please let me know. Just kind of write in the chat and I'll adjust accordingly as I have to. Okay, awesome. And these letters, I know I'm in the way now, but can you see what these say? Can you make it out? I'm going to go through it too. I just want to see like font wise and size wise, if that's good enough too. So hopefully you guys will be able to read the agenda, see the agenda. Okay. So I'm just going to lay down what we're going to be working on today, and I'll put it in the chat too. So what I'm going to be talking about today is an overview of the atom. I'm going to be talking about the parts of the atom. What are the subatomic particles? Where are they located? What does the periodic table tell us about these things? So like I said, we're going to start with parts of the atom, go into the location and charge of these subatomic particles, and then we're going to have the periodic table and then how the different pieces of the periodic table show us this information. So today I'm just going to focus on that, and then on the next stream we'll get into application. So for now, I just want to get into, the background basics, and then we can build off of it. Okay? So let's get started then. Okay, so like I said, I'm going to start with the basics of the parts of the atom. Okay, so there are three basic parts of the atom, and you guys know what those are. So we have our proton, we have the neutron, and the electron. Oh, by the way, a disclaimer, I didn't mention this yet. If you are watching this stream and if you take notes on the sheet of paper about what I am talking about, when the stream ends, take a picture, send it to me through Remind, and I will let this replace one of your assignments for the week. So for each stream that you go and you copy the notes down from what I'm discussing, that will replace one of your assignments. So whoever didn't hear that doesn't get the benefit from that. So if you're interested in, not having to do like the, the handbook reading, then you could easily replace it with this. Anyway, okay. So we have the three parts of the atom, which is our proton, our neutron, and our electron. Now, these have another name. It's not just called the parts of the atom, but these are called the subatomic particles. Okay, so subatomic meaning smaller than the atom. So smaller than the atom, a part of the atom. Okay, so when you guys are doing your reading or looking at questions and you see the word subatomic particle, it's literally just saying that it is a proton, a neutron, or an electron. Okay, so what do we know about the subatomic particles? So we know that protons have a positive charge. We know that neutrons have a neutral charge. And we know that an electron has a negative charge. But what we also know is the location of all three of these subatomic particles. So two of these particles are in the nucleus, and one of them is found in the cloud. And that's really going to be the main focus for today, is how does the periodic table break down information based on whether the particle's in the nucleus or whether it's in the cloud. So what I'd like for you guys to do is, in your notebook on a sheet of paper, is to create a chart that looks like this. And I'm going to be filling it in with you, and I'll just kind of hold up my notes and show you where I'm at so you guys can follow along with me. Okay, so I'd like you to make a chart that looks like this. Column for your cloud. And so every piece of information that has to do with the nucleus or the cloud, we're going to write in here just to kind of consolidate what you know about the atom and how it relates to the periodic table. So I'm going to write it down on my piece of paper, and I'll show you what I have, and then I'll keep you updated. Okay, so your paper should probably look something like this. So kind of like how I drew on the board. So you're going to have, wow, that line's not straight at all. Okay, so you're going to have one column for your nucleus and then another column for your cloud. And then we're just going to fill this in, okay? So let's start with the subatomic particles, okay? So we have, like I said, proton, neutron, electron. So the proton and the neutron both are found in the nucleus. So we're going to add both of those to the nucleus. And you probably want to kind of put beside it what their charges are, just for reference. So your proton has your positive charge, neutron has your neutral charge, and then your last subatomic particle is your electron, which is found in the cloud, otherwise known as your electron cloud. Now, I do want you to note the overall charge of the region, okay? So I'm going to kind of draw like an atom here. So we have protons and neutrons in the middle, and then we're going to have electrons floating around on the outside. So just kind of for reference. So something that you do need to keep in mind is that the nucleus has an overall positive charge, because the nucleus is made up of protons and neutrons. If neutrons have no charge, then the only charge of the nucleus has to be positive, okay? So I want you to note up under nucleus that it has an overall positive charge. Okay, and if the nucleus has an overall positive charge, then the region where the electrons exist, that must mean that that has an overall negative charge, which it does. So in the electron cloud, it has an overall negative charge. Okay, and I'm going to write that on my paper too, so we can be on the same page. Okay, so these are the three particles. We know their location within the atom. We know their charges. And then we also know the overall charge of the actual regions of the atom, okay? And this is important to kind of specialize between the nucleus and the cloud, because the periodic table gives different pieces of information specifically for what you need to know about the nucleus and specifically for what you need to know about the cloud. So let's go ahead, get into that. So I'm going to go ahead and erase this because I kind of want to leave the agenda on the board. Are you guys okay with me erasing this? And I can show you my paper too, because I wrote the notes down for myself. Okay. Vincent, can you shut that door? Can you shut the door? Sorry, if you hear background noise, it's my kids. Okay, so I emphasized a lot that you should always have your periodic table on you, and there's certain pieces of information you just have to know, okay? And it's not that like you have to memorize all of it, but you need to be able to know how to use it if you're given, you know, a periodic table. So I'm going to start with the nucleus. So what information the periodic table gives us specifically about the nucleus? So I'm just going to take one of these little squares, and then I'm going to blow it up here. I'm going to draw it for you guys. So I'm just going to do carbon because that's a really common example. Oh, I don't like this marker. Okay. Okay, so I basically took carbon off the periodic table and then just kind of blew up that little tile for you. So when we are talking about the nucleus, all right, when we are talking about the protons and the neutrons, that is when you kind of zoom into the periodic table and you look at each individual square, okay? So there are overall trends on the periodic table, but when we are looking at an individual square, that means we are focused in on one particular atom, and more specifically, the protons and the neutrons within that atom, okay? So I just want to put the table out to the side again so we can add to it. So I'm still in the nucleus part of the table. So the parts of this little square that give us information about the nucleus include every single thing on here. So our atomic number right here, our atomic number specifically tells us how many protons the element has, okay? So the atomic number tells us number of protons. So up underneath the nucleus, you can add a little bullet point that says the atomic number, because the atomic number is related specifically to the nucleus. And I'll add it on mine too. Arifa, hey, what I had said was that if you take notes on any one of these live streams, it will replace one homework assignment you have to do. So if you want to replace one of the homework assignments, like if you didn't do one today, this can replace that. Just take a picture of it right after the stream and forward it to me. It is not for a separate grade. It is for a replacement of a grade, so you don't have to do extra work. So that's totally up to you. Okay, so the atomic number specifically tells us number of protons. Now, it does also tell us the number of electrons, but it tells us the number of electrons in a neutral atom, okay? And very specifically know that I'm saying neutral atom. So in a neutral atom, that means the number of protons equals the number of electrons. So when your proton number equals your electron number, oh, that didn't help. That is the only time the atomic number gives you the same number, okay? So usually when you have questions that are about a specific element, it'll tell you like a stable element or neutral element, those mean the same thing. And when we get to the charges, you'll remember that, like group 8 has a charge of 0, that's what it's talking about. So when you have a stable element, that is when protons equal electrons, okay? And usually, I kind of mentioned this too, this is talking about the nucleus. This right here is giving you information about the nucleus. It is really not giving you information about the electrons. I can't think of really any electron question you will get based off of this information, okay? It's pretty much just protons and neutrons. Okay, So the next thing that also gives you information about the nucleus is your atomic symbol. So keep in mind that your atomic number tells you how many protons you have, but the number of protons tells you what element you have. So both of these things, the atomic symbol and the atomic number, tell you the exact same information, okay? So number of protons is what element you're talking about. And so that means that the actual element name is the same thing, right? So if an element has 6 protons, that means it must have a symbol of C. That means it must be carbon. So all 3 of these things are giving you the exact same piece of information. And then this is your element name. Okay. So now, here we have what's called the average atomic mass. So notice that it says average, okay? So I had mentioned before that when you see a mass that has a decimal, that it is an average of multiple masses, okay? Let me make sure, okay. So what I definitely want you to put up under here too for nucleus, and I wish I wouldn't have wrote this the way I did, but definitely put average atomic mass, because the atomic mass, and specifically average atomic mass, so both of them honestly, and give you information about the nucleus. Now, average atomic mass, like I said, has multiple masses in there. But what do I mean by multiple masses? So each element has multiple isotopes, okay? So an isotope is an element that has different mass than the other version. So like, imagine that you take your weight over the course of a month. Your weight's gonna fluctuate, okay? It's still you, but your weight fluctuates because maybe you have more water one day, maybe you have less water one day, maybe you just ate a lot. Like, your weight will fluctuate. Now take all those masses, add them together, and divide it by all of them. This isn't the correct formula, but just kind of work with me. And then divide it by however many you have. You're gonna end up with a decimal, okay? You're not gonna end up with a whole number. That's why this is not a whole number. This is the average atomic mass. So you have the multiple isotopes, and what they do is basically they say, okay, which isotope is found on Earth most often? And that's called percent abundance. So notice that the mass here is closest to 12. And carbon has a few isotopes, including carbon-12, carbon-13, and carbon-14. So since this mass is closest to 12, that kind of tells you, hey, on Earth, carbon-12 is the most abundant, and that's true. So when you're looking at these masses, the number of the mass that is closest, that the number is closest to, like for boron, it's like 10.8, then that isotope is probably gonna be boron 11, because if you round up, it's closest to the number 11, okay? So that is kind of helpful when we are dealing with the atomic mass, when we need the whole number, but that's why this is a decimal. Now, this year in physical science, you will not be asked questions about this, okay? In chemistry, you definitely will. In chemistry, you will have to be able to calculate either the percent abundance, or by given the different isotopes and the percents, you will have to calculate, okay, what is the actual mass? So just looking forward to next year. Okay, so what else has to do with the nucleus? The atomic mass. So atomic mass is something that you will have to calculate here. And the atomic mass is talking about one element, okay? So let me get a different marker. So the atomic mass is made up of 2 parts. How many protons you have, and how many neutrons you have. So why is it that we don't count how many electrons we have? So how come we only add the protons and neutrons in? Does anyone remember? How come we don't add the electrons in there? How much does an electron roughly weigh in AMUs? I'll give you a hint. It's so small it doesn't even matter. So the reason that we don't add in the number of electrons or the electron mass is because it's like 0. It's so small that it's totally negligible. So really, the atomic mass, how you calculate it, that is not something you have to memorize. So like, for example, if you are going to step onto a scale and you are going to weigh yourself, if somebody comes up to you and like snips off a teeny tiny piece of your hair, your weight's not going to change, right? So that's pretty much the same as an electron. The electron weighs so small amount that when we're trying to figure out how much an atom weighs, we don't need to consider it. At least not at this point. Theoretical physics, yes, but here, no. Okay, so atomic mass is your number of protons plus your number of neutrons. So let's do a practice calculation question. Now, what if on the test, they do not give you the mass number? What if instead they just give you an element and then they ask you to figure out how many neutrons it has? Well, that's when you're going to pull out the periodic table and you are going to round to the nearest whole number, okay? So let's use oxygen. So oxygen has a mass number of 15.9999. So really, we can just round that to 16, okay? So whenever you're working the problem, just take whatever the mass is, round to the nearest whole number. So if we round to 16, and let's say the question says, how many neutrons in an oxygen atom? Okay, so the mass number is provided by the periodic table. You can always look it up, okay? You will always have access to your periodic table, and it will definitely have the masses on there. There is nothing you need to even want to worry about or have to try to remember. Okay, so if our equation, which we'll use the equation since it's given, okay? If the equation says atomic mass equals number of protons plus number of neutrons, we are given the mass from the periodic table, so we can go and plug that in. So oxygen has a mass of 16 AMUs. And now the number of protons, that is always given by the periodic table, so we can look that up. So oxygen is atomic number 8. So it has 8 protons. Now we solve for the number of neutrons. So blank plus 8 equals 16, or if you like, 16 minus 8. So that would mean that one oxygen atom has 8 neutrons. Okay, so this is pretty much the sorts of questions you guys will be looking at. It really is not going to get any more complicated than this. You may see pictures, and then it'll be like pointing to the neutrons. You may have to kind of like count the neutrons or protons in the picture. But like I said, you always have access to your periodic table, but pretty much all the questions work like this. Okay, so if the question is asking you for how many protons, like they give you the mass, they give you the neutron, you do not have to calculate for number of protons. You can just read that straight from your periodic table, okay? So that's almost like, it's not like it's a trick, you can calculate it too, but that's one of those questions that's like a time waster. Like, it's easier for you to just be like, oh, I mean, whatever. Maybe it's just easier for you to calculate. If you can calculate quickly, great. Otherwise, just look it up on your periodic table. Okay. Oh my gosh. Alrighty. So are there any questions about what is atomic mass, the difference between average atomic mass and atomic mass, these two things? And I'm going to go ahead and erase this to give us some more space. Okay, so I mentioned it, but I didn't write it. And I do want to make sure you guys get this note down onto your sheet. I mentioned the word isotope. Please write that down under nucleus as well. Okay, so the nucleus, or the isotope, whether like which isotope it is you're talking about, by which element, depends on the nucleus, okay? Because an isotope is an element that has different masses, like I said, but what gives it the different masses is the number of neutrons, okay? So an isotope has different number of neutrons, meaning it's, you know, within the nucleus. Let's see. Do I want to say something else about that? Okay, so for the isotope, it does not affect the charge. When we are talking about isotopes, we are still talking about stable elements, okay? So stable or net neutral elements. So, and that's usually, right? Because if you add a proton, now it's not like you gained more positive charge necessarily. Like if you have an oxygen that has 8 protons, if you add another proton, it's not just the super positive oxygen. You literally change the element, okay? So now you would be fluorine instead. So even though adding more protons will, I guess, make the nucleus more positive, technically, if you're counting charge, but you change your element too, if that makes sense. So for isotope, I want you, like up under there, to add a note that we're specifically dealing with a neutral or stable element. Okay? So at this point, we are not talking about how many pluses and minuses does the element have. It's just totally neutral. You're adding more neutrons, it gets heavier. You take neutrons away, it gets lighter. That is pretty much the key concepts behind the nucleus. So notice that as far as dealing with the periodic table, the only part of the periodic table that deals with the nucleus is this individual box right here. Okay, so each one of these individual boxes is where you need to look if you have any information about the nucleus. Okay, now let's zoom out. So now let's start looking at the cloud. Okay, I'm gonna grab a pillow real quick because my knees hurt. Hold on. Okay, so now we're dealing with the cloud, and specifically it's called the electron cloud. But we can just leave cloud as we initially had it. Okay, so far what we know about the cloud is that this is where electrons are, and the electrons have a negative charge, and that the entire cloud itself has an overall negative charge. Okay, so when you were looking at the periodic table, the first things we started to talk about was the numbers that I had you add to your periodic table. Now, as I said, I cannot promise you that there won't be tests anymore since, you know, this whole us having to leave school. We really don't know what's happening, so we may have to give a final, we may have to give tests or something, at least some sort of assessment to make sure you understand. So just in case, please make sure you're able to do this because I cannot provide you with this information. You have to know this information. And what I'm specifically talking about is the charges and the valence electron numbers. Now, I believe the periods are given on the side. I'm not positive, but I think so. I'll have to verify that for you. The group numbers are given, but I think it says 1 to 18. And I really need you to know 1 to 8 because that gives you more information and it's more user-friendly. Okay, so let's start by on the top. If you have a periodic table, go ahead, pull it out. If you don't, maybe you can look at ptable.com or something. But okay, I'm gonna go ahead and start adding my valence electron numbers up at the top. All right, so group 1 has 1 valence electron, group 2 has 2. We skip the middle because those are transition metals, so it's change. You won't touch that till chemistry. We have group 3, group 4, group 5, group 6, group 7, and group 8. So these are our group numbers, and I will get into valence electrons a little bit later. Let's go ahead and put the charges up top so we can have that established. Group 1 has a +1 charge, group 2 +2, group 3 +3, plus or minus 4 for group 4, -3, -2, -1, and 0. So we have our groups numbered, we have the charges for each group, and let's also put the period numbers on the side. If it's already on yours, great. Mine's on here, but I don't think you can see it. Let me try to make it a little bigger. So 1, 2, 3, and I'm just gonna stop at 4 because I don't think you're gonna get a question beyond 4. I'm pretty positive you won't. Okay, so the next piece of information that you need to have about your cloud is about the periodic table. So each one of these numbers that we listed around our periodic table tells us specifically about the cloud. So I want you guys to add that under your cloud notes as well. So your group number specifically gives you information about the cloud, about the electrons in the cloud. Your charge tells you about how many electrons are being given or taken, so that's even more information about the cloud. And then you have your period. And remember that period has to do with the rings on the Bohr model, and then I'll kind of talk about that a little bit too, about how each period actually stands for an energy level. So yeah, you have the various energy levels within the atom. So, you know, the energy isn't created equal there. All right, so let's see. Let's get started with group versus period because that's something you guys are most familiar with. So as I said, number 1 through 8, those are the group numbers, okay? So this is group number 1, and a group is also called a family, okay? So group and family are used interchangeably. And that's a column, and that is vertical. Oh gosh, I can't spell. Okay, I hope that's right. And that is vertical. So all those things are talking about the exact same thing. So based on what sort of question you may see, all of those things are talking about the exact same thing. Group 1, family 2. All right, so the reason that we have a number, a group number, okay, is because this number right here represents the number of valence electrons in an atom. So let's go ahead and draw a Bohr model so you can visually see what I'm talking about the valence electrons. So let's do sodium. So what we're going to look at is we're going to look at the period number. So in order to draw a Bohr model, the period number tells you how many rings go around the atom. So sodium is in period 3. So period was the sideways. And let me kind of put that up here too. So period or row or horizontal, same thing. Okay. So the period number tells you how many rings. So sodium is in period 3. So we're going to have 3 rings around the atom. Oh, I don't like that. It's too light. Okay, so we're going to have three rings around sodium. Now, sodium is in group 1. So group 1 tells us how many valence electrons there will be. And so valence electrons means on the outer shell. So since we already know it's 1, I'm going to go ahead and just put it there just to see if we're right, if we build the model right. So with the Bohr model, the way you build it is you go left to right, top to bottom, you read it just how you would read a book, okay? So what you do is you always start with hydrogen in the top left, and you say in period 1 or in ring 1, how many boxes are there? So there are 1, keep going, keep going, keep going, 2. There are 2 boxes, meaning 2 elements in row 1. So we're going to put 2 electrons on ring 1. Right now we keep going. We start with period 2 or ring 2, and we count the elements, and we're just going to keep going until we get to our element, which is sodium. So ring 2, we have 1, 2, keep going, 3, 4, 5, 6, 7, 8. So on ring 2, we're going to have 1, 2, 3, 4, 5, 6, 7, 8. And then now we're on period 3. We're at sodium because it's in period 3, group 1, and we already put our electron for that, so we are finished. So the way that you verify if you did the correct Bohr model, 2 ways. First way, which is probably the quickest way, is how many electrons do you have on your valence shell? Well, there's 1 electron on this valence shell. It's in group 1. That means you probably did it right. The next way you verify is sodium has 11 protons, meaning it should have 11 electrons. Now, I did not talk anything about charge. I didn't say the word ion. I didn't say it was charged. So you can assume that it's not charged. Okay, so you can assume proton number equals electron number. So there's a total of 11. So if we count up all of these electrons, it should add up to 11. So we have 1, 2, plus 8 is 10, plus 1 is 11. We definitely did this Bohr model correctly, okay? And you should be able to interpret Bohr models, definitely. All right, so back to the valence shell. So the importance of this number right here, of the group number, is it tells us how many electrons are on the valence shell. So the reason this is important is because based on how many electrons are there, tells us how the element's going to behave. So all of the elements in group 1 are family because they behave the same way, because they have 1 valence electron. So the elements that have the same number of valence electrons behave, aka react the same way. All right. So when I say the word valence electron, I am talking about the electron that is the farthest away from the nucleus. And this is also important because remember what we talked about the charges, about how the nucleus in here is positively charged. So if the nucleus is positively charged and opposite charges attract, right? That means that these electrons close to the center are being pulled by those protons in the nucleus. They're not going anywhere. These electrons, a little bit farther away, are still close enough to be pulled in by those protons. They're attracted. But the ones all the way on the outside are far enough away that they don't get pulled in by that attractive force. So these electrons are free to move around. And they do move around, and that's how bonds are created. Okay? So I'm going to go ahead and erase this. Oh no, I didn't want to erase that. Okay. Okay. Okay, so we've got the valence electrons covered. Okay, and we've got the periods number. So let me say it again. We have the group numbers taken care of. We know what the group number is, what the group number represents, the fact that group number tells you number of valence electrons, which are farthest away from the nucleus in an atom. And those are the electrons that can move around and bond with other elements in order to form compounds. Okay? And the period number also tells us about the electron, but the period number tells us energy level. So like in that sodium atom we just drew, we had 3 rings. Each one of those rings represents an energy level. And when you guys get to chemistry, you will talk more about that and more about like the specific rules of how electrons fill into each energy level, because it's really not as simple as it sounds in this course. Okay, but we've got that. All right, now onto the charges. Okay, so charges actually have another name, which is actually more or less its real name. So charge is the same thing as oxidation number. Now for this class, we don't deal with reduction and oxidation. That is way beyond the scope of this class. But basically what oxidation and reduction are talking about is you have some atoms or some atoms in a compound that are gaining electrons, and it may actually not even be in a compound. So you have some atoms gaining electrons, you have some atoms losing electrons. So who's the donor, who's the acceptor? That's what oxidation is all about. All you need to know for physical science is that charge is oxidation number. Okay, it is the same thing. Please start getting used to whenever you see the plus or minus in your mind, be like, okay, oxidation. Because next year when you get to chemistry and you already have that background vocabulary, you're immediately gonna know, okay, electrons are coming and going somewhere. And it's just gonna make your life so much easier because that concept is actually pretty confusing. Okay, so we have the plus charges, we have the minus charges, and then we have zero. So we have the group that already is stable, doesn't need to do anything. So let's start with the positive charges. So what these charges in general are called, and I'm going to add that over here under a cloud, is ions. So an ion is a charged particle. So notice that when we're talking about the nucleus, we're talking about a stable atom, a stable particle. That meant that it didn't have charge. But when we are talking about the ion, now it does have charge, okay? So now when we're focused on the electron cloud, now we're like, okay, where are the electrons coming? Where are the electrons going? What is the charge? There is going to be a charge when electrons are lost or gained. That is the only way to create charge. Interesting. Okay. I'm gonna have to get back to some people in chat. Not cool. All right, so anyway, so ion means charged particle. Now, we have 2 types of charges. We have the pluses and we have the minuses. So we have cations, like a kitty cat, and those are positive, like a cat paw, okay? And then we have the anion, which is a negative charge. So initially you have neutral elements. So when elements are just sitting around by themselves, they're not doing anything, the proton number equals the electron number, they're neutral. But as soon as an electron starts to move, that's when it becomes an ion, okay? So when we're looking at the periodic table, when we're focused on the nucleus, we're assuming stable, not an ion. Electrons are not going different places. But as soon as we start zooming out, looking at the cloud, we're like, okay, we see the charges, that means electrons are moving. Now we're in the realm of ions, cations, anions, okay? So a cation has a positive charge, an anion has a negative charge. So in order to become a cation, or a positive charge. That means that an electron must be given away. So we can say electron lost, electron given, electron donated. It's all the same thing. So I'm just going to put lost / donated. Okay, so for a cation, you have an electron that is being given away. And that kind of makes sense because if an electron is negative and that negative goes away, that means that you're left with more positive. So if you started off with 6 protons and 6 electrons, well, now you lost an electron. So now you have 6 protons, 5 electrons. Okay, so that means that it's a positive charge. And that's exactly right. Now for an anion, that's the opposite. So for an anion, an electron is gained. So in order for an element to become an anion, it has to gain 1 or more electrons, okay? So it can gain 1 up to 4, depending which element it is. So notice that the charges are specific to the groups. So group 1 forms a +1 charge. Group 2 forms a +2. So that means all these elements, so for instance, in group 1, they only have 1 electron to give. All the elements in group 2 only have 2 electrons to give. Now, once we start getting to the center, like I said, you will touch this in chemistry. That's when you will go over this. These have multiple charges, meaning depending on their state, they could give 1 up to 10, 11 electrons. So it depends. So we're not even going to talk about that here. But same thing, group 3, 4, 5, 6, 7, they can only give a specific number of electrons or take. Now, once we get to group 8 will not give and will not accept any electrons because the entire goal of an atom is for each element to have 8 valence electrons. Once the element has 8 valence electrons, it is stable, it is complete, it does not need to react anymore. So basically, the element will do what it has to do until it drops to a neutral state, and then it can stay there. All right? So that is the entire goal of all these elements, is to either give, and by giving, they become positive ions or cations, or to take, where they become negative ions or anions, in order to become like a noble gas, which is neutral. Okay? So I mentioned a song in class. I will mention it again because it will definitely help you remember. You need to remember that 8 is the magic number, okay, as far as the electrons go, specifically valence electrons, all right? So I got 1, 2, 3, 4, 5, 6, 7, 8 electrons in my valence shell. 8, 8, 8, okay? Please remember 8. 8 means stable. Now, common questions include, why do electrons want to become stable? Why do atoms want to become stable? Why do atoms want to gain or lose electrons to have a full valence shell, meaning has 8 electrons? So when it says full valence shell, it means 8. And the answer is, so it can be stable. Because maybe it has to give electrons to become stable, or maybe it has to take electrons to become stable. It's all about stability. And usually the question will be specific. So why does this element want to donate 3 electrons or something like that? Okay, so another word for a full valence shell is to have an octet, okay? To have a complete octet, a full octet. When you see the word octet, oct meaning 8, okay? All of these words are kind of interchangeable, and you will definitely see them. Okay. All right, so I'm gonna add the notes onto my paper, and then I'll show you guys kind of what I have. And then I'll summarize. And if you have, the equal sign is because I didn't want to put just like a dash and then put what it means, because then it would look like positive and negative. So like what it's saying is like a cation, it means that an electron is lost or donated. Oh, what does it say after? My bad. It says electron is lost / donated. And that's what I'm about to write down on here too. Okay, so we have. Okay. So, just to summarize, the periodic table gives us information about the nucleus and about the cloud of an atom. You just need to be able to know, like which piece of information do you need for which test question, what is it you need to focus on. So like when you're looking at the periodic table, for example, if they ask you a question about how many valence electrons does an atom have, for you to know, okay, I'm zooming out, I'm looking at the full table, so I'm looking at the numbers on the table. But if you get a question that asks, which of the following causes a change in isotope, then you need to know to be able to zoom in and be like, oh, that's the mass. So just where do you need to pull what piece of information from? That is incredibly important, because once you can do that, you can definitely start answering any question that they throw at you. Okay, well, I think that pretty much covers everything I wanted to cover. Does anybody have anything specific related to what I was talking about that you want to ask? Okay, it doesn't seem like you do. If you do, let me know. You may be just writing like last minute notes down. So if you want me to do a specific stream on a specific topic, so we left off on bonding before we left school. I would like to pick up on bonding. I know that was something that was definitely very confusing to people. So I would like to put out videos, or especially be able to do the bonding live, so people can ask questions. And then there's also certain labs I want to do live too. So I'm going to be putting out some videos for you guys. I've already did one yesterday. I'm still editing it. But I'm going to put out like little videos, little instructionals, like how to do certain labs. And then once you guys do them, I want to like talk about it, discuss it as a group. So you guys can do fun stuff while you're at home too, not just sitting here doing paperwork, okay? But if there's anything specific that you're like, hey, I would really like to review this, please let me know so that I can prepare, get some more resources out for you guys. I promise I'm not going to give you any extra like work, but just resources, okay? So if you need anything from me, whether it is school related or not school related, please let me know. I'm here for you guys. And we're going to do our best and get through this together, okay? So here's just kind of my notes that I took. I accidentally put my little rag thing on it, so it's like all messy. But this is roughly what I got written down. I'm sure you guys got more, but these were the major topics that we hit. So, okay, Kayleana, I'll do it again, and then I'm out, unless you guys have anything else that you want to ask. All right, Kayleana, this is for you. Yeah, maybe I'll just hold you. Okay. I got 1, 2, 3, 4, 5, 6, 7, 8 electrons in my valence shell. In my valence shell. There you go, Kayleana. All right, I love you guys, and send me your notes on Remind. If you send me your notes, then you don't have to do today's assignment. All right, see you soon.